Greetings everyone, this is your captain speaking. Welcome aboard the Ascension. Thank you for choosing Solar Excursions for your tour today. We are currently the only space tourism outfit offering destinations to the outer solar system, so you're in for quite a treat today. Our tour will mostly consist of flybys of Jupiter and its 4 largest moons, which are referred to as the Galilean moons. Galileo was also the first to discover Saturn's rings, which he described as ears in his notes. Now that all our passengers are aboard, the attendants will make a quick inspection of the cabin before we undock from the orbital hotel. The Ascension is the first commercial craft to be manufactured with a new type of transparent composite material, essentially turning the entire passenger cabin into one big viewing window. Traffic control has cued us into a holding orbit for the Albuquerque Drive, so we should be underway in just a few minutes. I'm sure most of you are familiar with the transportation system, but I'll explain real quick for those who do not know how it works. The drive is a large torus or ring, about 20 kilometers in diameter. Basically, the drive works by bending the time-space around the craft, allowing it to travel like a surfer on the crest of a wave. The energy which powers the drive is absorbed from irregularities in the quantum foam which surround the ring. The Albuquerque Drive on the other end will intercept and accelerate us to the correct velocity for an intercept with Jupiter's sphere of influence. There are currently 3 drive units in the outer system, with 2 more in development. So, I hope you'll join us when the Neptune and Pluto rings are operational. Alright folks, looks like we're up next. Before the development of the drive, it took regular propulsion methods about 6 years to reach the Jovian system. Now, it takes about 6 microseconds. As you can see, it happens faster than the blink of an eye. If you look out the port side, you'll get your first look at the red-eyed king of the planets. Our first destination will be Jupiter itself. The ship needs to slow down enough to enter an orbit around the planet. In order to accomplish this, we perform a maneuver called aerobraking. This technique has been used as long as humanity has been exploring space. When an object enters the atmosphere of a planet, the friction from the molecules impart a small force which decelerates it. This is the reason that meteors glow when they enter the atmosphere back home. The only downside is that it is incredibly easy to burn up unless a special type of heat shield is used. We are entering Jupiter's radiation zone, which is created by the planet's magnetic field. Even at a distance, if we were outside in a spacesuit, we'd be instantly cooked by that radiation. Now, we're close enough to distinguish Jupiter's famous bands. These are created by intense jet streams of ammonia which flow in opposite directions. The darker orange bands are called belts, while the lighter ones are referred to as zones. They are organized by convection currents. Belts are made up of cooler air, as opposed to zones, which are warmer. It's also theorized that the planet's internal magnetic structure may have an influence on the shape and direction of the bands. We will be passing through between the South Equatorial Belt and the Tropical Zone, the 2 regions which border the Great Red Spot. The spot is actually a large pressure system which is believed to have existed 400 years. As you can see, the spot is located above the surrounding clouds, which is due to the fact that it's actually colder than the surroundings. We've officially entered Jupiter's atmosphere. At the moment, we're skimming around the outer clouds. Our trajectory will be taking us deeper into the atmosphere, where the clouds are denser. We will be expecting some turbulence, so you might want to buckle up. Yes? Do you have a question? Of course. Well, you can't actually walk on Jupiter because it doesn't have a proper surface. The easiest way to imagine the structure of Jupiter is to compare it to an onion. Jupiter is composed of mostly hydrogen and helium. Below the outer atmosphere, there's a region of dark hydrogen. This layer is something between a liquid and a gas. It's created from the atmospheric pressure and gravity. The reason it's referred to as dark is due to the fact that it doesn't transmit or reflect light, aside from infrared. Eventually, the pressure and the gravity become so intense that a layer of special type of liquid called metallic hydrogen is formed. Beyond this metallic ocean is a rocky core, most likely composed of silicates and heavier elements. Alright, ladies and gents, we have officially entered the King's Royal Court. Our first stop will be Io, the innermost of the 4 Galilean moons, and the most volcanically active body in the solar system. There are gravitational interactions between Jupiter and its moons, similar to the way that our own moon creates tides back on Earth. The tidal forces created by Jupiter's gravity stretch and squeeze the moon, so this creates friction and heat within their internal structure. This is why most of the Jovian moons are seismically active. The amount of radiation on Io is around 2.2 million times more than we receive back home on Earth, so I wouldn't recommend going for a stroll. As we continue our approach, you should be able to make out the plumes of sulfuric material which are ejected from the volcanoes on the surface. Many of these are actually much taller than Mount Everest. After the debris from the eruptions cools, it falls back to the surface as ice, which gives the moon its unique yellow coloration. Some of the volcanoes are violent enough to spew material out of Io's orbit. This material interacts with Jupiter's magnetic field and creates a faint ring of plasma around the planet. Next on our list of world subjects is my personal favorite. If you've never heard of Europa before, you might be surprised to learn that it may have the potential to harbor life. As you can see, Europa resembles a dry, dirty snowball. Their outermost layer is composed of a sheet of ice, ranging between 10 to 30 kilometers in thickness. Underneath the ice is a massive ocean of liquid water. Those small lines which cover the surface are called lineae. They are fractures in the ice layer created by the tidal flexing we discussed earlier. It's similar to plate tectonics back on Earth. Fissures created by the tides allow the warmer water beneath to be exposed to space, whereupon it cools and freezes once more. The brown discolorations are created by minerals, which are carried to the surface by currents of warm water. The real issue with the hypothesis that life could evolve from Europa's oceans is the radiation it receives from Jupiter. While not as bad as Io, Europa still experiences about 320,000 times the amount of radiation compared to our standard doses on Earth, although the thickness of the ice might assist in reducing the dosage. Our next destination is Ganymede, the largest moon in the solar system. It's actually larger than Mercury, but only about half as massive. Ganymede is interesting as it's composed of alternating layers of ice and liquid, which are distinguished by their salinity, or how salty they are. Moon systems are interesting because they are like mini solar systems. Most stars are born when a large cloud of molecular gases is disturbed. This disruption can be caused by many things, such as the birth of a neighboring star or from a nearby supernova. Once the effect is triggered, the cloud begins to collapse in on itself. As the core becomes more massive, it begins to spin and form something called a protoplanetary disk. The heavier elements, which are more massive, will end up closer to the star, while the lighter elements like hydrogen and helium will accumulate away from the star. That's why most rocky planets are closer to their stars, while typical gas giants are located beyond the frost point. The abundance of lighter elements is also the reason that the gas giants are much larger. A star is born once its gravity is great enough to achieve nuclear fission within the core. Once this happens, the solar wind will blow away all the remaining dust and debris. Callisto will be the last stop on our tour today. It is located outside of Jupiter's primary radiation belt, so it only receives about 5 times the radiation dosage we experience back on Earth. If you can tell by looking, Callisto has the most heavily cratered surface in the solar system. The crater we are passing now is called Valhalla and measures over 1,800 kilometers in diameter. The outer layer of Callisto is made up of rock and ice, which gives it a darker appearance. When an object hits the surface of the moon, it sends ice shards flying around the impact zone. These crystals catch the light and reflect it back, like snow. That's the reason they stand in contrast to the darker surface. Callisto is like the meat shield of the Galilean moons. Since it's the outermost of the larger moons, it has a greater opportunity to intercept any incoming asteroids. This is similar to how our own moon protects Earth, like a goalie in soccer. Well, folks, that's all for our tour today. Thanks again for choosing Soul Excursions. We hope to see you on more of our future tours.